Welcome back to the deep dive. Our mission today is a little different.
Yeah.
We're not parsing articles or analyzing quarterly reports. Instead, we're using the blueprint of a highly specialized technical certification.
The VCF 9.0 Advanced Architecture exam.
Exactly. We're using its structure as our core source material.
And that's a genius move, really, because an exam blueprint, especially at this level, isn't just a list of facts to memorize.
Right.
It's a consensus document.
Mm-hmm.
It's the industry basically putting a flag in the ground and saying, these are the absolute highest value, mission-critical concepts right now.
Absolutely. So just to be clear, we're not teaching you how to pass a test here.
Right.
We're extracting the strategic imperative. If you're building, operating, or even just planning a modern software-defined data center, the 10 concepts we've pulled out here, they really represent the mandatory future direction.
I'd say so. It's all about automation, high-velocity performance, and pervasive security.
The goal is to move you from just knowing what VCF 9.0 does to really understanding why the architecture is shifting this way.
And what that means for your strategy, your operations. This is about being truly informed on the concepts that drive efficiency and scale.
Okay, let's unpack this. And where else to start but at the very beginning? How this complex, highly automated environment gets built and maintained.
Right, the life cycle. Yeah. And that initial deployment phase is, well, it's arguably the most crucial.
Why is that?
Because VCS is designed to be automated from day one. You don't, manually install components one by one. You use specialized tools.
And that brings us immediately to the, let's call it the dedicated contractor for the initial setup, VMware Cloud Builder.
That's a great way to put it. Cloud Builder is a fantastic example of purpose-built tooling.
Meaning?
Meaning it is used exclusively for that initial automated imaging and bring-up of the VCF management domain.
So it's the construction crew.
Exactly. The crew that lays the entire complex foundation, perfectly aligned and level.
And it sounds like it handles a mountain of tasks right out of the gate. Validating hardware readiness, deploying the ESS hosts.
Installing the core components like vCenter, NSX, and the SDDC manager itself.
So here's the key insight then.
The critical strategic insight is that Cloud Builder's lifecycle is finite.
Finite.
Once that initial management domain is deployed and running, Cloud Builder retires. It hands the keys over to the SDDC manager for all ongoing management and lifecycle duties.
So it's a tool for deployment, not for operations.
Precisely.
Yeah.
And that separation of duties is really key to architectural stability.
That makes perfect sense.
Oh.
Once the foundation's laid, you need a facility manager, not the original construction crew.
Right.
Now, let's say that facility is up and running and we want to expand it. We can't just plug in a new server and expect the system to use it, can we?
No, not at all. There's a very specific preparatory state required.
And that state is?
Commissioned. It's the required status within the SDDC manager inventory before any physical server can be added to a cluster.
Okay, but why is that so rigid? Why can't the system just discover the machine and, start using it?
Because VCF architecture is based on strict known compatibility. Think of the commission status as a pre-flight checklist.
A quality gate.
It's a quality gate, exactly. It confirms that the hardware has been discovered, validated, and critically, that it has the correct firmware and meets all the VCF compatibility matrix requirements. It's designed to prevent inconsistencies from destabilizing a production environment.
That's a massive reliability improvement. But let's shift to ongoing maintenance. This is historically the biggest headache in data centers, right? Patching means reboots.
Which means planned downtime.
Which means late nights for administrators?
This is where VCF 9.0 delivers a huge operational leap, and it's one of the most exciting features in the source material. Live patching.
Live patching. So this promises to directly address that historical pain point of downtime. How does it actually work?
Well, it allows you to apply certain security patches directly to the running ESXi kernel.
So without a host reboot?
Without a host reboot and without having to evacuate all the virtual machines first.
Okay, now that's a big deal.
Think about the operational difference. Before this, applying a patch meant draining the host, vMotioning workloads off, rebooting, verifying.
And then moving everything back, the whole maintenance window.
That whole maintenance window is shrunk down to just minutes, and without interruption.
So as an administrator, my operational risk profile just changes dramatically.
It does. You're no longer planning a 3-hour window and just hoping the vMotion process doesn't fail 45 minutes in.
Right.
It fundamentally changes the role from being reactive, scrambling after hours, to proactive. You can apply security fixes immediately with minimal operational risk. It just shows the architecture prioritizes continuous security and availability.
Let's pivot from operational uptime to the core architectural drivers of raw speed. If VCF 9.0 is about maximizing performance, that has to start at the foundation storage.
And what's fascinating here is how storage design has evolved. We're not talking about incremental improvements. We're talking about the vSAN Express Storage Architecture, or ESA. This is not just an upgrade. It's a full reimagining of how vSAN handles modern NVMe devices.
We've heard all-flash for a while, but ESA is specifically for NVMe. What does that specialization let them do architecturally?
It lets them ditch the historical baggage of traditional vSAN disk groups, the caching tier and the capacity tier.
Which were designed around slower spinning disks.
Slower disks, hybrid setups, exactly.
Yeah.
Traditional vSAN had to do a lot of internal data movement, which leads to something called write amplification.
And write amplification is where you write data once, but the system has to write it multiple times internally to manage everything, right? Which just kills SSD lifespan and performance.
Precisely. ESA solves this by using a single-tier write system and a log-structured file system.
So it's a much simpler data path.
Much simpler. Imagine the old system was a complex, multi-layered highway interchange. The new ESA architecture is a dedicated, single-track bullet train line optimized only for high-speed traffic.
That single-tier approach.
Yep.
It has to reduce overhead and speed up recovery.
It does. It's built from the ground up to exploit the low latency and high parallelism of modern NVMe, giving you massive gains in performance and efficiency without all the traditional storage gymnastics. It just streamlines everything.
Okay, so we have this lightning-fast foundation. Now we need to make sure the workloads running on it are perfectly distributed. The machine behind that is the Distributed Resource Scheduler, DRS.
Right, DRS is kind of the tireless traffic cop at the data center. It's not a utility you run once a day. It's continuously monitoring hosts for imbalances in CPU and memory.
And if it spots one, say one host is hitting 90% CPU, while another is just loafing along at 30.
It automatically intervenes. It just balances the workload by migrating virtual machines using vMotion non-disruptively to the less utilized hosts.
And the goal is just to keep everything humming along smoothly.
The goal is to optimize resource usage and maintain consistent performance across the entire environment. It ensures every resource dollar you spend is fully utilized.
So it prevents that situation where you have plenty of physical capacity, but it's sitting unused because your VMs are all bunched up?
It's the ultimate utilization optimizer. It maximizes your investment while guaranteeing high-priority workloads get the resources they need instantly without anyone having to lift a finger.
Okay, shifting gears to connectivity. We've got our virtual environment humming along internally, but it has to talk to the outside world. That interface is handled by the edge cluster.
Think of the edge cluster as the customs and border control for your virtual data center. It hosts the NSX edge nodes, and its whole function is to provide services related to external communication.
And when we talk about traffic coming in and out, we use the term north-south routing. That's the edge cluster's main job, correct?
That's its primary role, yes.
Right.
North-south is external ingress and egress. It is the gateway. But it does a lot more than just routing.
Like what?
The edge cluster is where you get essential services like load balancing, NAT, VPN services. It's where the virtual network segments meet the physical network infrastructure. It is the definitive boundary.
So the edge cluster is really the point of translation, making sure your highly efficient internal system can safely and securely talk to the chaos of the outside world.
That's a perfect way to describe it.
Let's move now to our final and maybe most strategic segment, the control layer. This is all about how VCF 9.0 manages security, identity, and multi-site operations.
And when you build an SDDC that's this flexible, where workloads are constantly moving around, perimeter defense is just fundamentally insufficient.
You have to assume threats are already inside.
Exactly. And that is the foundational thinking behind microsegmentation.
This is a radical concept compared to traditional network firewalls. We're not talking about a single defensive wall, are we?
No. Microsegmentation applies firewall rules not at the network border, but right at the virtual machine or workload level itself.
And the key benefit, tying back to that workload mobility,
is policy enforcement. Because the security policy is enforced by the hypervisor, the fabric of the data center, that policy stays with the virtual machine.
regardless of where it moves.
Regardless of which host, which cluster, or even which geographic location it moves to.
That sounds incredibly secure, but I have to ask the critical operational question. Doesn't that just create a nightmare of firewall rules to manage?
That's a great point. And yes, it would if you did it manually. But the VCF architecture lets these policies be driven dynamically by things like tags and security groups, not static IPs. And the trade-off is worth it because it shuts down lateral movement of threats, that infamous east-west traffic. If one VM gets infected, the microsegmentation firewall stops it from spreading to its neighbor, even on the same network segment. That capability is priceless.
Okay, moving from workload security to user security. Managing all of this requires a consolidated identity system. VCF 9.0 introduces the Identity Broker Service.
Right. Previously, identity management could be fragmented. vCenter might have one identity source, NSX might have another. The Identity Broker Service is the federation layer that solves that problem.
So it's the single source of truth for authentication.
Precisely. It enables true single sign-on, integrating with external identity providers. So whether you're logging into vCenter, NSX, or an area service, the authentication experience and policy are identical. It's paramount for auditability and just simpler access management.
And that theme of consolidation extends beyond identity to just visibility. If you're running a large enterprise, you've probably got multiple SDDC instances.
One in Europe, one in Asia, one domestically.
And monitoring them all individually is just inefficient.
You need a mission control center for your data center fleet. And that is the role of the Unified Operations Console.
A centralized view across multiple geographically dispersed SDDC instances. That sounds like it simplifies global governance instantly.
It provides aggregation of critical information. It gathers health status, alerts, capacity insights, and compliance data from every linked VCF environment into a single pane of glass. It's critical for any large organization that needs consistency.
The power here is recognizing that VCF is designed for enterprise scale. The Unified Operations Console makes managing that scale actually feasible.
And finally, let's wrap up by talking about how VCF empowers the actual end users who need these resources, the developers, the engineers, while keeping that governance framework. This is the domain of area automation.
Area automation. So this is the self-service layer. What does that mean in practice?
For the user, it means speed. They go to a self-service portal, they pick the standardized VM or application stack they need from a catalog, and they deploy it instantly.
They bypass the traditional IT ticketing bottleneck.
They do, but for the administrator.
That's what I was going to ask. What about control? We don't want people just provisioning resources willy-nilly.
And that's the beauty of it. Area automation provides the policy-based governance layer. Every request goes through predefined approval workflows and policy checks. It ensures that while you're prioritizing speed, the resources still adhere to the organization's cost, security, and networking standards automatically.
It turns IT from a blocker into an enabler. That is a powerful synthesis of concepts, moving from a specialized tool for initial deployment cloud builder to a self-service environment with area automation, all on a bedrock of high-performance architecture like ESA. So what does this all mean for you? The sources detail a clear separation. Cloud Builder for setup, SDDC Manager for cluster management, and area automation for user provisioning. If these integrated systems are designed to eventually minimize human intervention through features like DRS and live patching, which automatically handle fixes and load balancing, what strategic role does the administrator play once everything is commissioned and running smoothly? The core expertise shifts entirely from performing manual tasks and reacting to crises to designing governance policies and optimizing the autonomous system. That's the important question about the future of expertise that this deep dive raises. Keep that in mind as you explore the next generation of data center management.